Good morning, everybody. I hope that everybody's having a great day so far and a great start to our week. Today's video is going to be all about everything slope. What slope is, how do we find it, how do we calculate it, everything like that. So please stick around for the video and you'll find out a little bit more. So let's get to it.
All right, everybody. Today we're going to be talking about slope. So, first question is, which graph is steeper? To me, it looks like B is generally steeper, so that's what I'm going to write. Question B is going to ask, write directions that explain how to move from one point on the graph to the other, from graph A to graph B. Well, it looks like for graph A, and I'm going to change my line color here, it looks like I have to move up to 2 boxes, and then I have to move to the right 3, 1, 2, 3, 3 times. So I know up to right 3. Okay. I know for part B, it looks like I have to go up 1, 2, 3, 4 times. Whoops, 4 times. Kind of hard to see there. 1, 2, 3, 4. And then I have to go to the right 1, 2, 3 times. So up 4, right 3. And part C is asking us to write the directions from part B as ratios and then compare the ratios. How does this relate to which graph is steeper? So I'm going to zoom out a little bit so I have a little bit more room to write. But I can see if I do like up over over, so like up over, I can write it as part A was 2 over 3 and part B was 4 over 3. And I know, let me make that easier to read 3, and I know that 4/3 is greater than 2/3. So that in fact tells me that this lines up with which graph was steeper. And this is actually how we think about slope. Slope is considered to be a rate of change, but it's also the steepness of a line, okay? How we change from one point to the next, what that ratio, that rate is. So there's a couple different ways that we can think about slope. The first way that we can think about slope is rise over run, that up down slash left right, okay? We can think about it in terms of the change in our y values of our ordered pairs over our change in our x values, or we can think about it using this formula. My second y value minus my first y value over my second x value minus my first x value. So I have an example here to kind of show you how we can go about finding slope using our slope formula right here. So what I need to do is I need to label these points using x1, y1, and x2, y2. That's simply just saying this is my first x value and my first y value, and this is my second x value and second y value. So I'm going to label this as x1, y1, and this is x2, y2. So all I need to do is I just need to take these values and plug them into the appropriate spots. So let me highlight where they have to go here really quick. Almost there. And then after I do that, after I plug it in, I just need to do the math. So I have 14 minus 5, all of that over 5 minus 2. 14 minus 5 is 9, and 5 minus 2 is 3. 9 divided by 3 is 3, so I know that my slope is 3. It's also important to know that we put slope as m, okay? So m is slope. But that's essentially all that we need to know about slope right now, okay? So let's go to our lesson summary. Slope is a number that can be used to describe the steepness of a line in a coordinate plane. The slope of the line is often represented by the symbol m. Lines in a coordinate plane that are left to right inclining have a positive slope, as shown below, and lines in a coordinate plane that are left to right declining have a negative slope, as shown below. Determine the slope of the line when the horizontal distance between points is fixed at 1 by translating the point Q. So essentially what they're saying is you should be able to go from one point to the next in order to figure out what the slope of that line is. So again, please feel free to use this formula that I have all the way at the end here, y2 minus y1 over x2 minus x1, when we are trying to determine the slope of a line. But that's all that I have for this video. So continue to have a great week, and I hope that you have a great rest of your day. See you next time.